Hey Logic students, this is your Professor O, and we're going to start our unit on constraint satisfaction and using TFL and truth tables to determine our options. Alright, so basically what I want to prepare you to do is tackle a problem that looks like this. Alright, I admit these are kind of artificial looking, so you'll have to bear with me here, and we'll just kind of work through how to do these things, right? This is kind of stuff that comes up on your midterm, so I just want to make sure you understand how to do it, okay? So you wish to invite 3 people to a dinner party. We got Ashley, Brad, Christine, and Dudley, but of course relations among them are a bit touchy. So here's the deal: Ashley will not come if Brad does. Brad will come only if Christine is also present. Christine refuses to come if Dudley will be there. So, can we convince 3 of 4 people to come? All right, so what do we got to do here, right? How do we go about doing this, all right? What's going to be the method? What's going to be the procedure? And so what we're going to do is actually use our logical language and give a step 1. All right, we're going to identify the choices that we got to make and then represent each one with an atomic formula. The reason why we're going to do that is because choices, at least in the constraint satisfaction world, are often binary, okay? You're either going to choose to do the thing or not. And there's lots of different choices you have to do, and so that's how we're going to conceive of the choice. They're going to be binary affairs, all right? So in this case, what we got here, we have 4 choices, right? And so we'll give them a name. Right, we're gonna have Ashley come to the party, Brad come to the party, Christine come to the party, and Dudley come to the party. So you see how I'm parceling out the names there. I'm gonna use the C predicate for be come to the party or choose to come to the party. Okay, all right. So that's gonna be how I'm gonna set things up. All right, and then the next step is I'm gonna identify my constraints. Right. And the way I'm going to do this is I'm going to make a compound formula from my atomic ones, and these need to come out true whatever the case may be. All right, so I do have constraints listed to me in English. All right, so here we have something that's telling me that Ashley will not come if Brad does. All right, so what type of sentence is this? Well, it's a conditional because of the word if. And it's one of those, it's like, okay, so where's the antecedent and where's the consequent? And you might think that this is the antecedent and this is the consequent because that's how, conditionals look in TFL. All right, but that's not the case for us, actually. We got to think about it like this. Suppose Brad comes to the party, right? Then Ashley will not come. So if Brad comes, then Ashley will not. You got to kind of think about it like this. So Brad's coming is sufficient for Ashley's not coming. So if Brad comes to the party, then Ashley will not come, and so that's how we're going to translate it, right? We're going to use the not here to we have that signified by the negation, and so Ashley will not come, right? If Brad does. So if Brad comes, then Ashley doesn't. This is one of these things in English where the consequence being mentioned first and then the antecedent, okay? By contrast, Brad will come only if Christine is also present. All right, so let's just think about that. Brad will come only if Christine is also present. That's not, so that's a little different from this one. Ashley will not come if Brad does. Brad's coming is just sufficient for Ashley's not coming. Okay, but that's not saying something like that. Brad will come only if Christine is there. So Christine's present is a necessary condition, right? It's a necessary condition. So if Brad does come, Christine's going to be there, all right? So that's how we're going to translate it, is like that, okay? So here we have the antecedent in English being mentioned first and then the consequent being mentioned second. Now, a lot of students mix this up. They think, well, gosh, if it says only if, isn't that a biconditional? And it's not. It's not a biconditional. Okay, we have here as just a conditional, and it's just saying that Christine's presence, is necessary for Brad's presence, And so if Brad is there, if he's there, well then that's sufficient for Christine being there, okay? All right, I hope you see that. It's a little tricky to understand, all right? But if you think about it, you know, just kind of go back, maybe re-listen to that. You'll see what's going on. All right, so here again we have another conditional, and it doesn't say only if, it just says if. So Dudley's being there is going to be sufficient for Christine's not coming. So if Dudley is there, then what? Right? Then Christine will not be. So that's how we're going to translate that. Okay? So here in English, the antecedent's being mentioned first and then the consequent. Right? So what I want you to take away from this is that if you see if by itself, consequent always comes first. If you see only if, then antecedent is coming first. Okay, so that's what I want you to understand. Keep that in mind. Okay, all right. So that's step 2. Right. Step 3 then is that we're going to identify any numerical constraints we might have and determine whether these need to be satisfied. Okay. So in our case, we want to invite 3 guests. Right. Can we do it? Well, a truth table can help us give us the answer. Right. So steps 4 through 6 are just truth table steps. We make a truth table for all the constraints. We include any numerical evaluations as some additional column that we needed for. And then we find a row or rows of the table in which all the constraints are satisfied, right? And then in those rows, we check to see if we meet our numerical constraint. So the big question then is, can we invite 3 guests, right? Can we invite 3 guests? All right, so we look at this. Here's the table. Yikes, it's 16 rows long. That's because we got 4 choices to make here. And as you can probably tell, right, these ones in blue, those are the ones in which we're satisfying our constraints, right? So they're all true, right? We want those to all be true because those are the choices that are available to us given the kind of constraints that we have, okay? So these other choices here, they're off the table. We're not going to be farting around with those. All right, we want to take a look at these. Now, do we satisfy any of our numerical constraints? How do we even get this? You know, this is the column of the numerical constraints here. And you might be wondering, how did you get those numbers, right? Where did those come from? Well, let's look at row 1 here. In row 1, we are choosing for everybody to come. All right, we're choosing for everybody to come. And so we count up the number of choices made. 1, 2, 3, 4. All right, and so that's what gives us the number 4. All right, now we only end up satisfying one of our constraints. We don't satisfy these 2, so this isn't really open to us. All right, so what we got to do then is look at these where we are satisfying our constraints and then see if we do it. Okay, so can we do it? All right, we look down there, okay, and we see that we can't. We can't invite 3. Okay, so in this case, right, you know, A is being invited, C is being invited, you know, and the max number you're getting is 2. Notice that you satisfy your constraints when you invite no one. Isn't that interesting, right? Yes, of course. Okay, right. It's kind of vacuous because you don't get to, you know, accomplish any of your goals. But we can invite 3 people. These people just don't get along, so boo-hoo for us. Okay. So that's going to be the answer. Now I want to dwell a little bit on step 2 because it's the hardest. This is the translation portion of the class, and this can be kind of difficult for students. I think this is probably the most challenging part of the first half of the semester, personally. But you know, this might come easy to you, so we'll go over some of these things. Basically, what I'm going to do is I'm going to refer you here to this cheat sheet, and what we're going to have is kind of the English equivalents here that can be rendered into TFL, right? So notice, right, that you have, you know, right here in TFL you got negation, you know, and that's going to be signified by not clauses, or it's not the case that, right? P is false, it's another one. Then conjunctions, here you have P and Q, P but Q, P because Q, P nonetheless Q, right? Those are all conjunctions which can be satisfied by the ampersand. You got to pay attention here to the or symbol, right? P or Q. Is it, you know, is it an inclusive? You have to determine that. You know, in our class, I'll tell you if it's not. Okay, I'll tell you if it's not. Right? For the most part, anyway. Okay, so I want you to kind of understand that. Well, there's some exceptions to that. I'll go over those. All right. Also, the word unless, P unless Q. That actually translates as a disjunction. As awkward and as counterintuitive as that may be, you might not think that's the case initially, but I'll show you why it is, okay? Unless is a disjunction, all right? So be mindful of that. Same thing with exclusive ors or unlesses. Okay, this is different ways that you can render an exclusive or. So here you have the two conjunctions where one of the conjuncts is negated, disjoined together by the disjunction. That's going to be an exclusive or. Or what you can do is you can actually create a biconditional that's negated, or a biconditional that has one part of it negated. That's also going to be an exclusive or. Okay? All right. I chose some interesting music this time. I didn't know that it was going to be this dancey. It's kind of bugging me. So I'm sorry if it bugs you too, but this is just, I'm halfway through this thing, so I'm just going to keep going. All right. Or actually, you know what? I'm not. I'm actually going to change this. I'm actually going to pause here and take care of business. Okay, we are back. Sorry about that, students. And now I can think. Yay. All right, so here we are. Okay, we have again, this is the cheat sheet. Refer back to this, study this. This is important, right? Conditionals, right? Conditionals can come up in a lot of different ways in English. So you have the if P then Q. Also, like whenever P then Q. P only if Q. P only when Q. Q if P. Q when P. Right, Q provided that P, Q given that P. And then this is also weird here, right? Not P unless Q. Wait a second, wasn't unless up here? Wasn't that a way of translating a disjunction? Yeah, you're right. Exactly right. However, if you have a not P unless Q, that actually can be translated as a conditional. Again, I'll show you why that's the case, okay? All right, biconditionals, if P, then, P if and only if Q, P when and only when Q, P then and only then Q, right? P just in case Q. Those are ways of translating biconditionals, okay? All right, so here's some translation examples, right? We have if John goes to the party, then Amy does not. Right, that's a nice, easy one, okay? You got an if-then statement, antecedents being mentioned first, right? John goes to the party, then Amy does not. Okay, that works out pretty easily. Secondly, right, we have at least Bob or Carl goes to the party. So this, you might be thinking, okay, is that an inclusive or an inclusive? Well, the word at least should be able to tip you off there, right? That one or the other or both goes to the party. Okay, so that's going to be an inclusive or. So you just set it up like so, right? G is your goes to the party, Bob, Carl, right? There you are, right? Dwayne and Kate must both go to the party. Okay, so this looks kind of like a strong statement. What's saying is that they both have to come together. And when you have you need these two things together kind of statements, well, then you're going to have a conjunction. Because conjunctions say you got to have these two things together. Right? And that's what's being said here is that Dwayne and Kate must go to the party. Okay, Dwayne and Kate must go to the party. Okay, either John and Kate go together or neither go. Oh, okay, so that's kind of interesting. There's different ways of rendering this. All right, you can say something like this. John and Kate, right, are going, or neither of them go, right? So so they go together or not either of them. See, you kind of see how they're both negated there. So that's one way of doing it. You could also say this. John will go if and only if Kate goes. Okay, that's actually going to work out the same way. That's just fine. All right. Okay, so that's how you can translate stuff like that. Now, when you come across tough cases and you don't really know what to do, right, especially like this, Laura is not on duty unless Fred is. One thing you can do to kind of work through this in a principled way, is you assign your names to people and figure that out. Figure out what predicate you want to use and just be consistent, all right? That's the first thing to do. And then what you can do is you can actually send up an informal truth table, right? So an informal truth table is going to look like this. Here you have, right, Fred being on duty and Laura being on duty, right? So those are the two choices you have to make. There's 4 different possible ways that those choices could be made. And then you can make a column where you just have your English sentence, Fred is not on duty unless Laura is, and then you just go row by row. And then ask yourself this question: can you speak the truth under the conditions given to you in the truth table? All right, so let's look at row 1, where both Fred and Laura are on duty, right? So you know, can we speak the truth? Fred is not on duty unless Laura is. And actually, what's tough about this is that there's kind of a question mark here. We actually don't really know. We need to know more about the context, okay? Perhaps it's the case that Fred cannot be on duty without Laura, right? That would be an inclusive reading of the unless, all right? So perhaps Laura's being on duty is sufficient for Fred's not being on duty. Okay, this would be an exclusive reading of unless. So, you know, it's unspecified in our sentence. Okay, and so what we're going to do as a class here, if it's left unspecified like this, we're going to default to the inclusive. Okay, all right. So in this case, what we're going to do is we're just going to think of the. Okay, so if Fred is on duty, you know, then Laura's got to be on duty because Fred is not on duty unless Laura is. So that's going to come out true. Right, that's going to come out true. Right, I hope you see that, because you know, it's just necessary for Laura to be on duty if Fred is. That's kind of the way we're going to read this. But now, all right, let's think about the case where Fred is on duty and Laura is not. Okay, and then I assert Fred is not on duty unless Laura is. What have I said? Have I spoken a truth or a falsehood? Okay, and the answer is I've spoken a falsehood. Right, so I put an F there. Now, let's just think about the case where Fred is not on duty, but Laura is. Can I speak the truth when I say, Fred is not on duty unless Laura is? Yeah, I can speak the truth. I'm innocent until I'm proven guilty here, right? This is kind of how we're interpreting things. And suppose neither Laura nor Fred are on duty. Does that function as a counterexample to the claim, Fred is not on duty unless Laura is? And it doesn't, right? That can be true. I can speak the truth. So there I have my truth table. I've now translated this thing, right? And notice my little pattern here. It's TFTT, which is the same pattern as the arrow formula. So I can actually translate this as DF arrow DL, meaning if Fred is on duty, then Laura is. Right? That's a way of translating Fred is not on duty unless Laura is. Right, and that actually kind of corresponds with the truth conditions of the arrow, all right? Because arrows are true, right, if the antecedent's false or the consequent is true, all right? So that's why we kind of say not unless P, I'm sorry, not P unless Q can be translated with the arrow, all right? And so in that, the unless there, of course, is inclusive, right? All right, so just want you to kind of see that. You can also translate it like this, right? You could say not DF or DL. That would be another adequate translation of this English sentence, and that would work. Let's give an example of an exclusive unless. All right, here's an exclusive unless. You have John is invited to the party, and so I'm going to use I for invited and John, you know, for J for John and H for Henry. So this is saying John is invited to the party unless Harry is. John is invited to the party unless Harry is. All right. So why don't you work on this? All right. So let's make a little truth table here, and let's kind of break things up. And you know, I get a little more informal here. I don't like, you know, make the rows over here on the right. I just kind of have things broken up as is, right? So here's John is invited to the party. That's going to be TTFF. And then Harry is invited to the party. That's going to be TF. Okay, so I got all 4 combinations. Now I'm going to figure out whether or not, right, things are true. Okay, so suppose both are invited. Right, what happens to my statement? John is invited to the party unless Harry is. Well, that comes out false, right? That comes out false. The statement is not true, okay, because both were invited. And then I say, suppose John is invited but Harry is not. Right? Or no, I'm sorry. Suppose it is the case that John is invited and Harry is not. And then I say, John is invited to the party unless Harry is. All right? Well, that comes out true, okay? That's compatible with the state of affairs. That's okay, all right? And then if John is not invited and Harry is, and then I say, well, John is invited to the party unless Harry is, again, I've spoken something that is compatible with the state of affairs. That's true, all right? And then it's also true even if neither are invited, right? Well, John's invited to the party unless Harry is, all right? Well, neither of them were invited, so you know that's I didn't say anything false there. Okay, all right. Okay, so what I have here is an exclusive or, as you can see. Now, there's one way of writing that. You know, you can figure this out by normal form. All right, so this row right here is you got John being invited to the party and Harry not being invited to the party, or John is not invited to the party and Harry is. Right, I did some normal form there and I just translated it. That, you know what, that works. You can do that. That's okay. Right, like I said, it's an exclusive or, okay, which is represented here. Right, so I translated it like so. All right, I could have translated it though using this kind of format as well. That would have been fine. Okay. All right, so I know that was kind of quick. All right, and you should refer back to this little slide here when you're doing the practice problems. And these practice problems, I'm actually not going to go through these with you. I want you to work these out, okay? Because these are your homework problems. Okay, so these are going to be coming up on homework 6, right? So the answers are embedded in the slides here. Right, I'll just kind of give it away, right? But I want you to kind of work through these things first to see what you do, and then look at the answers, okay? Because that's where you're actually going to have a learning experience. Okay, you're not going to have a learning experience if you're just like looking at the answers and then giving them to me, right? I want you to work through these. This is kind of your responsibility to do this. Okay, you're taking this class online, right? You got to do the work the way I'm telling you to do it to have the learning experience that I want you to have. Okay, so work through that, do that. Shoot me an email, you know, hit me up on Google Hangout, and I will talk to you later.